Welcome, everyone in person and online. It's my pleasure today to introduce two esteemed speakers. We'll start actually with Joydeep Biswas, who is an associate professor of computer science here at UT Austin. He's also the associate director of Texas Robotics, and I've just learned has a keen interest in astronomy data. So that's exciting. So he's won many awards, including NSF Career Award, but notably for this talk, he was the Associate Program Chair of AAAI-26, and today he's going to talk about AI-assisted peer review at scale, and I'm excited to hear what he has to say.
Thanks, Stella. Thanks for having me here, and thanks for the kind introduction and allowing me to talk about this. So I want to talk a little bit about the AAAI-26 AI review pilot. I want to first start by acknowledging the huge team we had to do this. This is a huge effort. It required tireless hours of work by the whole team. So I really want to first appreciate all of this. And that includes Chad and Matt, who are the program co-chairs, and Kiri and Matt were associate program chairs, and we had an amazing set of workflow chairs. And Jesse's also a collaborator on this project. Okay, so this is a Cosmic AI talk. So before we get into AI peer reviewing, I felt it's important for me to talk a little about something Cosmic AI related. So I'm really into astrophotography as a hobby. I wanted to share with you a photograph that we took, a bunch of amateur astronomers using a facility just 2 hours to the west of UT Austin. I have a 75 millimeter refractor out there, and we collected more than 1,000 hours of data of this target. This target that you're seeing is SNR, a supernova remnant, G126. What you're seeing over here is red. It's hard to see because the lights are on, but you have access to my slides and you can look at them later. But the red stuff is emissions by hydrogen alpha, and the blue stuff is emissions of oxygen 3, right? What's interesting about this is that there's a lot of faint filamentary structures, and these structures only show up in very deep, long integration. I got into this because this is really a signal processing and probabilistic inference problem, which really ties to my primary research, which is in robotics. And it gives me a sense of wonder to understand the universe. What's amazing here is that we did this 1,000-hour capture, and we made 2 discoveries. One is a new planetary nebula candidate. It got named after our names, the BK. It's in the order of the last names of the authors, P. Biswas, that's me. So there's this little faint emission over here. It's never been seen before. There's a central star which is related to that. It's in the IRAS catalog. And there needs to be a lot more follow-up instructions. So, hey, if you have access to 1.8 meter telescope or something like that, come talk to me. We would love to have follow-up spectroscopic observations of this. So that concludes for me personally the cosmic part of the talk. Back to regular scheduled programming. What I want to talk here about is what are we trying to do, right? What's the challenge, right? So first of all, the scientific peer review is definitely under significant strain. And I think everybody knows this, right? I'll give you the numbers over here from the AAA perspective. Hi, Matt. Matt is associate program co-chair and was in the thick of things and having to deal with this massive growth. In 24, there were 10,000 submissions. In 26, there were 30,000 submissions, right? Reviewers are overloaded. New discoveries are made in an increasingly shorter time scale, and it is becoming increasingly difficult to maintain the quality of reviews at the scale needed. At the same time, there have been recent advances in AI for science. There have been significant advances in logic, mathematics, scientific reasoning capabilities. We see every day, almost every day, a new model beating the math Olympiads or whatever have you, right? And putting all of these two together, the key question that comes to mind is that can AI tools actually assist in the scientific peer review process? So when I raise this question, there are 3 top-level open questions that come to mind. First of all, are these state-of-the-art AI systems even technically capable? Are they even up to snuff, right? Secondly, how do they compare to human-written reviewers? And third, how can they be effectively integrated into the review process? So these are the big motivating questions which made us really take on this pilot, right? And once you have these high-level questions, there are a bunch of low-level questions about the AI system capabilities. And these are the usual questions that everybody asks, or the questions that come to mind whenever you tell someone that you're going to do AI for reviewing, which is, are they even going to provide any meaningful feedback for research which is by definition completely new in the field? Will they just hallucinate errors or just make stuff up? Will they just write positive reviews, sycophancy, to please the reader? Will they hallucinate citations? That's a very common question, right? And there are many of these low-level questions. And luckily, these are not questions which have gone unanswered for a long time. Lots of people have been working in this field, right? This is just a small selection of previous work. This is a snapshot of the state of the art. When we did the study, things have advanced quite a bit since then. But over the field, what I would roughly say is that there are many synthetic or post-hoc studies. There's some limited use of state-of-the-art simulated reasoning models or tool use, and that's very important for state-of-the-art. Things have changed a little bit there, and there's some limited real-world studies. But by at the end of the day, I mean, the thing which I want to say is that there had been no full-scale study with AI-generated reviews in an actual large conference with real papers that no one's ever seen before, right? Prior to AAAI 2026. So then I want to talk a little bit about the main track review process, right? And some design decisions that we had right from the get-go are these, right? So we want to make sure that no human reviewers are replaced in the review process. We want to make sure that the AI reviews don't make recommendations or score papers. They will only provide factual information, right? And confidentiality and data privacy were upheld to the highest standards. We had zero data retention, right? And we also want to make sure that papers were subject to the same review process across the board, right? So unfortunately, this is why we chose not to do an RCT within the conference, because we wanted to make sure every paper is treated exactly the same. And I understand like the tension one way or the other, but this is what we chose, okay? And we wanted to make sure that we use absolute state-of-the-art, no holes barred, to understand how this could be done, right? And this was supported by a very generous sponsorship by OpenAI, which allowed us to use their biggest models in doing this, right? And the process and workflow was extensively tested and refined in collaboration with the AAAI conference and ethics committees, okay? So what did we actually do? So to tell you exactly what we did, it's worth understanding how the AAAI review process works. It's a little bit different than some other conferences. There's two stages. In the first stage, papers receive an initial set of reviews, and any paper which has at least one positive review is promoted to the stage 2. And in stage 2, it gets additional reviews. There's author rebuttals, discussions among the reviewers, and then decisions are made. So with this substrate, here's what we did. In phase 1, one additional and clearly labeled AI-generated review was introduced in phase 1. No scores or recommendations were made by the AI review, and we did not ask the reviewers or program chairs to have to use this anyway. It was just additional information there if they wanted to use it, okay? There were no humans replaced in the process, and reviewers, SPCs, and ACs could view the AI review after reviewers after submitting their own scores could see it, but SPCs and ACs could see it anytime, just like how other reviews work. The other thing that we did is that we introduced an AI-generated summary meta review with agreement or disagreement among the reviewers, and it included attribution. Okay, I'll talk to you a little bit about how we did this. So this is the process. I want to talk a little bit about what we built, right? And usually when round about this time, I get a question, which is, what's the prompt, right? And I want to first definitively answer that question and say there is no single prompt. I don't even know how to answer that question because there is no single prompt. It is a very a detailed multi-stage process, okay? There are many steps going on, and there's a lot going on here. But I want to say a few thoughts here, a few things here. We have many steps. First of all, there's a paper pre-processing where we resample everything to convert images into a fixed and consistent resolution. We actually include structured markdown using a machine learning model, almost here. Thanks, Kyle. And to extract math and LaTeX notation and tables. And then we have several stages, each with different tools to perform different tasks. This was not built at one go, and it was definitely not built in the order that's being listed over here. We had to test, and to test this, we had a test suite of papers where we were looking at the reviews being generated, what is being picked out, how to improve them, and so on, right? I'll give you one specific example, and just in the interest of time. So in this, in the technical accuracy checking, at one point, we introduced this code interpreter. What this allowed the language model to do is that it would come up with equations and would actually program them in Python and test inputs and outputs to check for correctness, which was great. It was actually able to do a lot of technical checking, but then we found a problem. Sometimes it was misreading the equations. So that's when it really struck us that we really need to improve the equation that's getting. And that's why I went back and checked a whole bunch of OCR methods. At the time, Almost OCR was by far the best. So we went with that, and that's what we're using over here. Okay, that's just one example. There's been lots of similar findings that we had. Okay, I want to pause here and just briefly mention a challenge with AI review and benchmarking. There are many existing benchmarks at AI reviews. You'll find hundreds of them at this point. Existing benchmarks, however, either require human interventions, so they require humans to say yes, no, good, bad, or they assess one specific property, technical errors or reading figures or citations, whereas a review is supposed to do a whole bunch of different things, right? Or they require structured output, like they require JSON output or a very structured, very technical English form or so on, not full reviews. Benchmarking is still a big open challenge. We have some big work in this, and I can't talk about it now, but we'll have more to talk about. So the system that we built was designed for scale, and here's a dashboard of in the thick of things. We got the papers, we kicked off the running process, and you can see all of the stages, the different stages of the review increasing as time goes. The takeaways, first of all, here are that all reviews were generated in less than 24 hours. It costs less than close to $1 per paper, right? The total number of tokens consumed were of the order of 38 billion. To give you a context what that number means, it's a very large number, right? GPT-3 was trained by with of the order of like 300 billion tokens. So we're not that far off, okay? So we discovered unique challenges, right? So we discovered things like full papers. There can be huge variation in the number of tokens that they use. Roughly every paper takes off the order of like 20,000 tokens. You can have errors in reading equations and tables, which really meant that we need to do OCR. But once you do an OCR, you actually end up with a discrepancy between the OCR and the PDF, and the review process does not know which one to trust more the other, right? There are some big problems in cost and time scaling, right? So here's a spreadsheet that I had, which is that the pipeline that we had takes about 25 minutes to run per paper. The number of papers that we're entering that particular stage was about 22,000. And we're limited by some number of requests per minute, and we're limited by like the tiers. What level of parallelism do we need? 128, 256, 512, or 1024, and how much time would it take? What we interestingly observed empirically is that latent hallucinations are completely out of the blue, not so much of a big problem with these state-of-the-art models. They don't, and because of the way we set it up, it doesn't really make up citations either too much, right? Also, revealing author identities also turn out to be not a problem. Okay? I'm going to pause here and take two questions. There's a question here and then.
I was curious about like the PDF. So you mentioned like you downsample them to a specific resolution. Like I've seen that like breaking down when you have like log scale axis when some ticks are smaller, or so how do you deal with that?
Yeah. So great question. So here's the thing. So the author guidelines explicitly state what should be the minimum font size and all, right? We chose a particular resolution. It was 300 dpi, and 300 dpi is something at which if you follow the guidelines, it should be readable. If it's not readable, it's going to misread it, and it's unfortunately like it is a problem if you chose a font size too small. Okay.
Yes. It's also seen like intersecting curves. Maybe it's a detailed thing. But...
Oh yeah. Yeah. And you can talk about that offline. Yes.
That was actually also my question. Did you like, how did you check whether figures, etc., were still legible?
Yeah, so we checked whether, first of all, we had a test set of papers, but we also made sure that anything that the author guidelines said that you must have fonts, I believe it's like 8 points in the figures. It is very well represented. Actually, 300 dpi allows you to get even like 6-point fonts. It's not a problem. I think it's plenty sufficient. Just some low-level details. So the OCR model I said is almost CR. The base LLM model that we use is GPT-5. We had 0 data retention set in, which means that not only is the data not used for training, which is table stakes in this game, it's not even saved to disk. When a query goes to OpenAI, it stays in memory and comes back, nothing hits the disk. We use high reasoning effort, the highest level reasoning effort, and we use this new thing that they had at the time, Flex tier, which allowed us to get lower costs. We used a code interpreter and web search tools and ran with 512x parallelism with an interruptible workflow. Makefiles are amazing. Old computer science is awesome. You should definitely use Makefiles, okay? Checkpointing with Makefiles and graceful backup for retry. Each paper, I think I'd said, takes about 20 to 25 minutes to complete. And the OCR took about 12 hours on one 8x H100 server. And all of this entire process took less than 24 hours. And we had this crisis when we saw AAAI 2026 getting 30,000 initial submissions. And we're wondering, how are we going to review all of this? We scrambled to get a bunch of all of the human reviewers. But then I remembered after we finished this process, I pinged Chad and Matt and said, hey, worst case scenario, you at least have an AI review for every paper. So that was at least something. Okay, so how do we have to do the oversight? So an oversight that we had is that we want to have a combination of automated quality checking, where a critic LLM was explicitly asked to check for specific concerns. And I'll list some of these examples, right? And we had specific checks for intrusion checking, things like prompt injection that you might have heard of. We absolutely detect for them and we rejected papers for that. We had manual oversight as well. We manually sampled reviews at every stage for deployment. During the stage, I was reading basically hundreds of reviews per week over the process. And we requested SPCs to identify issues. And they successfully identified several issues caught, right? Some of the questions that the LLM checker was doing was checking for things like policy violations. Does the review reveal the author entities? Absolutely should not happen, right? Does the review raise ethical concerns? And a whole bunch of questions like this, right? So all of this output would get saved as a spreadsheet over all of the 22,000 papers, and then we'd actually sample through them and check what's going on. And anytime anything said, yes, we want to go back and check what actually went wrong. Interestingly, by the way, we had one question down here which says, does this review appear to be generated by an LLM? And everything was generated by an LLM, right? It only rated roughly 30% of our reviews as being AI generated, which just shows you that this AI generation is like a cat and mouse game. The latest models have capabilities which like the previous detection things can't check, and they catch up, but it's a cat and mouse game. Matt, you have a question?
Well, you said it only flagged 30, but do you have any idea if that number is at all accurate?
It's completely wrong, right? Because it's 100, we're talking about 100%. These are all the AI generated reviews, right? So it's completely wrong. Yeah, we were just curious. We just threw that in there just to see what it would say.
Separate from the part where you were looking at the assessment of the reviews themselves.
We'll get to that later. Yes, Jesse.
Have you tried kind of other more specifically things that are more specifically built for this, like Pangram or like GPT-0?
You're right. No, at that time they did not exist at this scale. Now we can do that, and we're talking to them. Several of these models, but you're right. Yeah. And now they're actually these specific models. You're absolutely right, a lot better. Okay, but we can come back to this. We want to understand how much energy we're devoting to this effort. I want to share some caveats though. So the caveats here is that the base model that we're using is a closed model. We have no idea how large the model is. There's some conjectures outside in the community as to how large it could be. And based on that, the TLDR is that the amount of CO2 emissions as a result of this is of the order of 28 passengers flying JFK to Singapore round trip. And Singapore is where the conference was held. So that's kind of like this. Okay, so what do the AI review have? It has a brief synopsis of the paper, a summary of the review, clear strengths and weaknesses, constructive suggestions for improvement, and highly detailed feedback. Here's an example of such a review. It's extremely detailed. And it has math notation in it, right? It talks about like weaknesses in algorithm 2 and lemma 2. There's a likely notational slip, et cetera. This is a particular review for a best paper award. We closely inspected it and we found it to actually have meaningful points found, right? Here's an example meta review. It would summarize things like the reviewers X, Y, and Z agree that whatever is relevant. Weaknesses, consensus amongst the reviewers about something, and then points of disagreement, and a one-sentence summary, right? Okay, so I told you a little bit about what we built. I want to talk a little bit about the survey, responses, and analysis. Okay, so here's what we did. We had two parts to the survey, and that had a part about this review, so feedback for the specific review that they were giving feedback on, and general impressions over assessment of AAAI 2026 reviews and sentiment towards AI review in general. This is a study which was reviewed by the IRB at UT, New Michigan, and UL Alberta. it was quite a detailed survey. It was not a lightweight survey. There were many questions, and I just have this here just to show that we have a lot of questions and there's some variations. Some that only went for the reviewers, some that went only for the authors, some that only went for the AI reviews. But we also did this for the human reviews as well, not just the AI reviews, human reviews as well. We got a lot of responses across the board. We got roughly 5,800 responses, 5,834. And we got responses for the AI reviews as well as the human reviews. There are a lot more responses for the human reviews from the authors because there are a lot more human reviews. That makes sense. Okay, so overall, was this actually useful? So we asked the question, where the AAAI 2026 AI review is useful. So we find that 53 agreed compared to 20% disagree, right? And in the future peer review process, people are even more positive. 61% agree compared to 14% disagree. Okay. Comparing human versus AI reviews. So all of these questions had Likert scale questions. We had distributions like this. And what we did is that we compared the means of these distributions for the AI reviews versus the human reviews. And there were 9 criteria for where we judged each review. So it had questions like, is this a review, a thorough review for the conference? Did it raise points that I had not previously considered? Did it accurately convey the significance and impact, right? So it had 9 such criteria. And what this plot is showing is that values on the right are AI preferred, values on the left are human preferred. Negative sentiments have been flipped so that positive towards AI is consistently on the right. Okay? So the high level takeaway is that on average, on 6 out of the 9 criteria, the AI reviews were actually preferred to the human reviews. So this is the mean. What's the significance or the uncertainty? The p-values that we have are exceedingly small because of the sample sizes that we have. So we ran the Mann-Whitney U-test to actually check whether these samples are drawn from an underlying same distribution or not. And it rejects the null hypothesis that this underlying distribution is the same by very, very strong p-values. The largest p-value that we have is 10 raised to minus 6. Okay. This difference between the human and the AI reviews is much stronger. This effect is much stronger for authors. This is the response from the authors. So it's much stronger there. It's much weaker for the reviewers, the senior program chairs, and area chairs. Okay? And there's a reason why, and I'll come to that later. Now, a question that comes to mind is that how do all of these responses change as a function of whether the paper was accepted or whether it was rejected, right? Here's how that breaks down. So the left column is for papers that were accepted. For the right column, it's papers that were rejected. The first row are the human review, responses to the human reviews, and the bottom row is for the AI reviews. And these are all survey responses from, sorry, let me just see if I can just close this. Okay, there we go. These are all responses from the authors. So the first thing that stands out is that there's huge variability in the human reviews, which actually, unfortunately, as scientists, it shouldn't come too much as a surprise. The second thing is at the peak of the AI reviews to the right, and you see this tighter distribution. This is a consistent finding across most of the questions that we asked. Okay. Okay. Now, we want to understand how do these correlate with prior impressions. So we had a question. Did you overall go in thinking that the AI reviews would be useful? And roughly 57.8% of the respondents said yes to various degrees. And we also asked them, does this review demonstrate capabilities beyond what I expected from AI? And despite most of the people thinking that would be useful, we're also surprised to find that roughly 55% thought it was demonstrating capabilities beyond what they expected from AI. Okay. So let's come back to the big open questions that I had raised. Are state-of-the-art AI systems actually technically capable of understanding and engaging, right? How do these reviews compare to human written reviews, and how could these tools be effectively integrated? I have a lot to say on all of these. I'm just trying to distill everything down, but here's my distilled down responses. So the first one, yes and no. They are actually capable of catching technical errors, sometimes including deep technical errors, right? But no, they're limited by the ability to read math correctly and has difficulty ranking severity. It can find technical errors, but it's like, is this a paper changing technical error? Or it's like, okay, it's something small that can be fixed, right? How do these state-of-the-art AI reviews compare to human reviews? On average, the authors prefer AI general reviews in 6 out of the 9 criteria, okay, with lower variance. And then how can they be effectively integrated into the review process? More work needed, a lot more work needed, okay? I want to conclude with some personal opinions, okay? First, this is an extremely polarizing topic, okay? And I think that should not come as a surprise. Second, and this is actually something which I understood only having done this entire thing, there is no single optimal review. The focus on the review needs to be customized depending on whether you're targeting the authors, reviewers, and area chairs. And we see this in the reviews. The level of detail that the reviews have is great for the authors because they're getting a lot of detail level feedback to improve their work. They love it. We've had authors come back to us unprompted and say, this is the best review we've had from AAAI ever, right? But the reviewers that consistently don't like it because it's just way too much, right? So the reviewers are trying to understand, are there correctness issues that are major? And the area chairs are trying to think much higher level. They're trying to understand, do the contributions and the significance outweigh the issues, and should that be accepted? So there is no single optimal review and needs to be optimized, right? I do definitely think that the technical capabilities are sufficiently advanced to be helpful, but they're not infallible, right? Human insight is absolutely crucial, and advancement of science is very much a human endeavor, right? And it's easy to build a system to expose potential benefits. It's not that hard to build a system which can expose potential benefits of AI. It is much harder to ensure that the same system cannot be misused. Any system which has potential benefits is very easy to misuse, right? And that's the really difficult part. But I do believe, I hold out hope, and I strongly believe that there exists a way to synergistically merge human and AI capabilities such that peer reviews is both enjoyable and effective. You just have to find the way, right? So I want to come back to the team, and I want to have them be up on the slide, and I can take questions in the last few minutes.